Alright, so if you're watching this video, you're probably familiar that there's a lot of jargon used to just classify particles in particle physics. And when you first start out trying to learn what all these terms really mean, it doesn't really help to read Wikipedia saying things like fermions are particles that obey the Pauli exclusion principle. So in this video, I'll be explaining and simplifying as many particle terms as possible in a crash course style video to help make learning about particle physics a little bit easier. To start off everything, fundamental particles or elementary particles are particles that are currently known to have no substructures, meaning that they cannot be broken down any further. These particles are listed in the Standard Model of Particle Physics. Examples of these fundamental particles include quarks, leptons, and bosons.
Although fundamental particles and elementary particles mean the same thing, it should be noted that both terms aren't always synonymous with subatomic particles. A subatomic particle describes any particle that is smaller than the atom. Therefore, a subatomic particle can refer to a proton, an electron, or even a Higgs boson since they are all smaller than the atom. However, a fundamental particle only refers to subatomic particles that cannot be broken down into smaller substructures. So quarks, which have no known substructure compositions, are considered fundamental, while protons, which are known to be composed of quarks, are not considered fundamental. A good way of thinking this is thinking about the statement that all squares are rectangles, but not all rectangles are squares. Simply, all fundamental particles are subatomic particles, but not all subatomic particles are fundamental particles. After knowing what a fundamental particle is, the next term to know is a composite particle. A composite particle is just like what it sounds like, any particle that is made up of smaller particles. A composite particle can be anything from a proton to a water molecule. Now let's get deeper into the lingo of physicists with fermions and bosons. In particle physics, all fundamental particles are either classified as fermions or bosons. By definition, fermions are fundamental and composite particles that have a half-integer spin, and bosons are fundamental and composite particles that have an integer spin. Basically, all fundamental particles have a spin value to them, but luckily, you don't have to memorize too many numbers here since there are currently only 3 possibilities of spin values for a fundamental particle: 1/2, 1, and 0. All fundamental particles that have a spin value of 1/2, which are quarks and leptons, are classified as fermions, which leaves fundamental particles that have a spin value of 1 or 0 being classified as bosons. And just as how fermions can be categorized into quarks and leptons, bosons can be categorized into vector bosons, which have a spin of 1, and scalar bosons, which have a spin of 0. And ultimately, the bosons that act as force carriers, which are currently the photon, the gluon, and W and Z bosons, are known as gauge bosons.
If what I just said was kind of confusing, the cool thing about this video is that you can just rewind and watch everything that I just said over and over again to help everything sink in. And I promise you can do this to me as many times as you want, and I really don't care or mind at all. Alright, if you think you got a firm grasp on the fundamental boson and fermion jargon so far, then you might want to hold on a bit. It's going to get a little bit trickier, but don't worry, you don't need to have a physics degree from Yale to understand this.
Remember when I said that fermions are fundamental and composite particles that have a half-integer spin, and bosons are fundamental and composite particles that have integer spin? You may be questioning how composite particles are either classified as fermions or bosons. You can figure out if a composite particle, say a proton or even a hydrogen atom, is either a fermion or a boson by knowing how many smaller fermions make up the composite particle. Composite particles composed of an odd number of fermions are also classified as fermions and are also known as composite fermions. while particles composed of an even number of fermions are classified as bosons, also known as composite bosons. You might want to hear that sentence again if you didn't get it the first time. A proton is composed of 3 existing quarks and therefore is considered a fermion with a half-integer spin, as it is made up of an odd number of quarks, which are classified as fermions. A hydrogen atom, on the other hand, is made up of 2 fermions, the proton and the electron, and is therefore considered a boson with an integer spin, as it is made up of an even number of fermions. If you have heard that bosons are force carriers before, and if you're wondering why a hydrogen atom can be classified as a boson, it is crucial to acknowledge that although bosons can act as force carriers, they don't have to be force carriers at all to be classified as bosons. All a boson really is, in the eyes of the scientific community, is a particle that has an integer spin, and some of them, but not all of them, happen to be force carriers. Remember, definition speaking, fermions are particles with a half-integer spin, and bosons are particles with an integer spin. Although it is usually true that fermions tend to make up matter and bosons tend to be force carriers, they don't always have to have those characteristics, especially with bosons, and that is the most important thing to understand from this video.
Alright, if you understood everything I had to say so far about fermions and bosons, then give yourself a pat on the back. You just got through the hardest and longest part of this video. Everything else from here on out will seem to be a lot easier. You might have heard the word hadron before, as it's the name of the world's most powerful particle collider as of today in 2016, the Large Hadron Collider.
What a hadron is simply a composite particle of quarks held together by the strong nuclear force. Hadrons can be further classified into either baryons or mesons depending on how many quarks are involved. A baryon is a composite particle made up of 3 quarks and is therefore considered a fermion. Examples of baryons include protons and neutrons. A meson is a composite particle made up of a quark and an antiquark, and is therefore considered a boson. And examples of mesons include kaons and pions.
And that's everything for this video. Hope this crash course on particle physics terminology simplified and clarified most of the terms that you hear physicists use willy-nilly. If you want to learn more about particle physics in sweet and short videos like this one, check out more of our videos on the Physics Paragons channel. Thanks for watching, and see you again next time.